Hey guys, it's Mr. McHugh. I've got an example to share with you on how to solve a right triangle for all the missing side lengths and angle measurements when you're given a few of them to start with. So here's a right triangle. You'll see the capital letters label the angles, and then the lowercase letters are the labels for the sides. We already know that angle C, capital C, is a 90-degree angle since it's labeled in the diagram as a right angle. We're told that angle B is 26 degrees. And we know that the hypotenuse side length C has a length of 20. So that's what we're given in the problem. What's left to find? Well, we need to figure out what angle A's measurement is. We need to know side length A and side length B. And we'll take them each one at a time. The angle A, of course, is the third angle of the triangle that we don't know yet. So we know C, we know angle B. In order to figure out the measurement of angle A, we just need to subtract angle B's measurement, 26, from 90 to figure out that angle A is 64 degrees. The two non-right angles in a triangle obviously add up to 90 degrees, so that the sum of all the angles is 180. So that's why angle A equals 64 degrees. Now, how do we get the side lengths? Let's label according to the location of the given angle, angle B, 26 degrees. That makes side length A our adjacent side, and it makes side length B over here our opposite side. So knowing that the angle B has a measurement of 26 degrees, knowing the hypotenuse, side C is the hypotenuse, has a length of 20, we can use a trig ratio to solve for side length A in this case. And so what trig ratio is going to include the adjacent side and the hypotenuse? Since we know the hypotenuse, which one accomplishes that? That's going to be our cosine. So the cosine of the included angle, which is 26 degrees, is equal to the ratio of the adjacent side, which we don't know, A, over the hypotenuse, which we do know, is 20. So solving for A, we're going to multiply both sides of the equation by 20, and 20 times the cosine of 26 degrees. If we plug this into our calculator, making sure the calculator is in degree mode. You don't want to make the mistake of trying to calculate this in radian mode. If we do this in degree mode, we get 17.976, which actually rounds up to 18.0 if we round to the nearest tenth. So side length A is actually 18. And we're going to figure out side length B in a similar manner, only now B is the opposite side. So we're going to use the trig ratio that includes the opposite in the hypotenuse, which is the sine function. So the sine of 26 degrees is equal to the opposite, B, which we don't know, over the hypotenuse 20. Again, multiply by 20 both sides of the equation, and calculating 20 times the sine of 26, we get that B rounds to 8.8. So after using the trig functions of the angle that we were given, we've solved for the two missing side lengths, and we had previously solved for the one missing angle measurement. We now have here all angle measurements and side lengths, so we've solved the right triangle.